Hello students, today we are going to learn about back propagation of the book. So what is meant by back propagation? So back propagation, by the name itself, when we have an error, we'll again go to the back layer and we'll change the weight. So it is called as back propagating. So it is an effective algorithm used for ANNs in feed-forward neural networks. So we have seen forward pass and backward pass. So it will use feed-forward network where you will get the input of like output of one neuron as an input to the next neuron or next layer. Okay, so it is an iterative algorithm which will reduce the cost and always the weights have to be adjusted. Every epoch will check the weight, will check the bias, and will remove the error with the help of the gradient. Okay. So before this, I want to show you exactly how the back propagation will work. So what exactly we are going to do now? We have already seen what is a neural network. Okay. So you will have here. Suppose if I take these are three neurons. Okay. I'm giving input x1, x2, x3. So I'm taking three inputs x1, x2, x3, and I'll have the related weight w1, w2, w3. Okay. Again, I'll draw one more layer, or you can draw a number of layers. So these are your hidden layers. Okay. These are your hidden layers. Again, finally, I'll generate one output layer. This is called as output layer. So this is our input layer. Okay, input layer. Here we'll have the hidden layer and we'll have the output layer. So whenever I'm moving again, I'll have this corresponding weight for this, weight for this, weight for this. Again, in order to calculate here, I'll have weight, here I'll have weight, here I'll have weight. And we have two types of output. One is target output and what I got, that is your actual output. Suppose my target output is 1. After calculating this complete process, I get only 0.6. Now here my actual output is 0.6. Now what is the error I am getting here? So it is 1 minus 0.6, that is 0.4. So I have to reduce this error. So this can be done with the help of back propagating. So what I'll do, I got here output 6. So again I'll change the weight. Okay. Then also I'm not getting here required weight. Again I'll go back. Again I'll change the weights. Again I'll go back. I'll change the weights. After changing everything, again I'll do the same thing. So what exactly we are doing? Whenever I'm getting an gradient error, so what I'm doing, I'm back propagating the whole network in the backward direction. So this is called as back propagation. Okay, so this is called as back propagation. Suppose for the first attempt, I'm getting 1. So my target is 1. I got 1. There is no error. So I don't do any updation in the weight. So this is the process for the back propagation algorithm. So for every epoch means for every time we'll change the weights. We'll calculate the gradient of the error and we'll change the weights. Now what is back propagation? Same thing. So computing the gradient in the back propagation will help in the reduce of the cost function, and it will always can be implemented with the help of the chain rule from the calculus, and it will have multiple complex layers where we can work on all these layers. So it can use we can use here. So here we can use gradient descent or stochastic gradient descent for calculating the error in the required output. So how to calculate the actual output, the difference between actual and target output can be calculated with two methods called gradient descent or stochastic gradient descent. So now all of you try to understand here. So I have inputs. I have input 1, input 2, here input 3 and input 4. So these are the hidden layers. This is H1, H11, H12. One means first layer and first neuron, first layer, second neuron, first layer, third neuron. Similarly, H21, second layer, first neuron, second layer, second neuron, second layer, third neuron. All this will compute, will get the output. If the output is exactly what we were expected, there is no adjustment. If output is not, there is a gradient error between the target output and exact whatever we got. So I have to go in the backward direction. So the weights of the each layer have to be updated. So this is the exact process of back propagation. So what we are doing, we are checking the target output and whatever the output we got, we are comparing with the help of the gradient descent. And in order to minimize the error, I'm going in the backward direction in order to get the reduce the error, and we will get the exact output. So what are the advantages? First one is ease of implementation. So if you don't require more about the neural networks, it can be easily implemented. It will be easy for the new learners, okay, who know only the basics about it. Only the thing is we have to identify the what is the error we got and how much we have to update and what is the learning rate. Simplicity and flexibility. So it is very simple to answer, easily understand, and it is very flexible for various scenarios. So we can use for anything, recurrent networks or convolution neural networks. Only the thing is we have to calculate the target vector minus actual vector. What is the error? Then how to minimize the error. Efficiency. Since we are making the weights unless until error is reduced, so the efficiency of this particular algorithm will be always high. Generalization. So this can be used for any type of data, unseen data or whichever we have the ambiguous data, because we are only targeting the error. So if you don't have error, we are not worried. If you have error, then we are only just changing the weight of that particular layer. So it is generally we can use for any models. Scalability. So it is very scalable. As we increase size of the data, so also it will not increase the complexity of the network. So finally, so it will be the basic advantages is ease of implementation, simplicity, efficiency, generalization ability, and scalability make this particular back propagation algorithm very popular. Now, so what is the working principle of back propagation? So if you see the working principle, so we have two passes, one is forward pass and one is backward pass. So forward pass we have seen. So whenever you are moving from one layer to the another layer, it is forward pass. When we are getting any error that is from, there is error between target output and actual output, we are moving backward. So that is backward pass. So these two both combinedly will have the back propagation. So how does the forward pass work? So just I'll show you the diagram, then we'll see. Okay. So for in the forward pass, what I'm doing A and H1. So first I'll calculate according to the A, according to the weight, the value of H11, value of H12, and value of H1. Then I'll calculate according to this H11, I'll calculate the H21, H22, H23. Similarly, how many layers, hidden layers I'll have, I'll calculate in this direction. Okay. So I'll start from here, move to here. So I'll start from here, move to here. Finally, I'll get the output. So when I'm getting the output, all the hidden layers are computed parallelly and we'll get the output. So this particular pass is called as forward pass. Now, so in forward pass, input is fed into the input layer. All the input or raw data they can be used for training. The input and corresponding weights are passed to the hidden layer. The hidden layer performs a computation and it will calculate H1, H2 are two hidden layers. The output of H1 can be used as input of the H2. Okay. So the bias will be added. So this is a forward pass. So again, we have to calculate the weighted sum of inputs. The activation function is applied for everything. If the activation function is accepted, your output, it will be fixed for the layer. Otherwise, again, we have to change the weight. Okay. So this is the forward pass, and this will be done until unless we'll get the complete final output, that is final prediction after completing all the hidden layers in between input and output. So this is your input layer. So if you observe here, so we have N1, N2 and N3 are input. So W1J, so this is related to H1. Okay, so again it is H2 connectivity to J, 3J. So these are the three ways. Again from H1 to output we have W1K and W2K. W1 implies here H1 weight and K is your output layer. So this is an example. Now, how does the backward pass work? Okay, so 1 second. So this is clear. After calculating the output, suppose I have an error over here. So what I have to do? First I have to adjust these weights. Then also it is not changed. I'll move to back. So again, these weights have to be changed. So this particular pass is called as backward pass. Okay. So this particular pass is called as backward pass. So how we are going to calculate the error here? We are calculating the error with the help of gradient descent or stochastic gradient error method. So this is the mean square error. So what is the error here? Predicted output minus actual output whole square. So this formula can be used in order to get the error between desired and predicted output. So once we have done the calculation of the error, what we have to do? You have to go back. You have to minimize the error in order to go for. So what we are doing? We are crucially going back in order to calculate the objective weights. So what we are doing? So we have to determine the gradients for each weight and bias in the network in the backward pass. Okay, so two things you have to remember. Forward pass, we are calculating the output, what exactly we are going to get. Then we'll calculate the error and you will move backward in order to minimize the error. So we'll see one example. So we have the y value is 0.5 and learning rate is 1. So this is our example. So if you see here, we have two neurons, x1 and x2. So this is the weight for first x1 to 1, that is 0.2, and x1 to 2, that is 0.3. X2 to 1, it is 0.2 and 0.3. And finally here from H1 to O3 is 1,3, H2 to O3 is 0.9. So this is the example given over here. Now, how to calculate a weighted sum? We know that Wi into J into Xi. Okay, and this is a formula for calculating after the hidden layer, that is Yj, Xj represent the value of the jth input and Yj equal to Aj. So first we'll calculate the summation of the output, that is all the layers within the weight and X1 value, that is input value. Then Yj of equal to function of Aj equal to 11 plus E minus Aj. So this is the formula we have to remember. Again, f of Aj equal to 1 plus E minus Aj. Okay, Aj into 1. So this is your final output value. So where Ii is the output value. So we'll see the example, then you can easily understand. Now, if you see the network, we have x1, x2, h1, h2 are the hidden layers, o3 is the output. Now, what we have to calculate first one is, we have to calculate y3, y4, y5. So these are the values in the forward pass we have to calculate. So how to calculate? First from y3. In order to get the y3, I have to take these values into weight values. Okay. So now at A1, so this is our value here. So first we are calculating H1 node. So at Y3 we are going to calculate. So how we are going to calculate? First we have to calculate the AJ. It is a summation of all the values. So AJ, A1 equal to W1 into 1 X1 plus W2 into 1 X2. So if you see here, so what is our value here? Weight 1. So 0.2 into 0.35. So 0.2 into 0.35 plus, what is the second one? 0.35 into 0.3. So that is 0. Here 0.35 into 0.2 plus what I am going here 0.35, 0.2 into here this value. Okay. So first one is 0.2 into 0.35, that is 0.2 into 0.35. Next step. what I have, what is the next value going to H1? 0.2 into 0.7. Okay. So 1 second, I'll tell you. So what are the values? What are the two arrows I'm getting over here? So this particular arrow and this particular arrow. How to calculate the summation of these two values? So 0.3 into 0.2 plus 0.7 into 0.2. So that will be your y3. Done. So 0.35 into 0.2 plus 0.2 into 0.7. So this what we have calculated with the AJ, that is A1. Because I'll have multiple values. So first one I'm representing as A1. So I get 0.28. Now I should calculate the Y3. Now I got the value. Now I have to calculate the Y3 value. So Y3, Yj of Aj equal to 11 plus E minus Aj and Yj equal to F of Aj, that is 1 plus E minus Aj into 1. So simply I'll substitute Y3 equal to 0.28. In place of Aj, I'm going to add 0.28. So when I substitute this particular E value, 1 plus E minus 0.281, it is equal to Y3 equal to 0.57. Okay. So simply we are going to substitute. So this is related to H1 node. Now coming to the A2. So I'll go to the figure. What will be the A2 now? What are the values I'm getting over here? So 0.3 into 0.35 into 0.3 and 0.7 into 0.3. Okay, so here 0.3 into 0.35, 0.3 into 0.7. So 0.315. And same formula I'm substituting here y4 equal to 0.315. So 1 plus e minus 0.3151. So I'm getting, when I'm substituting the complete values, I'm getting as y4 value as 1. So y4 value is 0.5. Now, one more output I have, it is A3. So I got these two values. Okay. Now it is 0.57 into 0.3 plus 0.59 into 0.9. Yes. Yes. Okay. So yes, exactly. 0.3 is 3 into 0.57 plus 0.9 into 0.59. It is 0.702. Again, I'm substituting the same value, so I'm getting in the 0.67. So when I'm getting here 0.67. Now what exactly we have done here? 0.35 into 0.2 plus 0.7 into 0.2. That is my, after substituting in the phi function, I got 0.57. Similarly, I got 0.59. And when I do this one, again, I should get the value. So 0.57 into 0.3 plus 0.59 into 0.9. Again, I substitute in Wi-Fi, I'll get 0.67. Okay. But when you go to the problem, starting we mentioned that actual output should be 0.5. Okay. But what output we got here? I'm getting 0.67. So I have to reduce the error. Yeah. So error j equal to y target minus y. So error equal to, actually I should get 0.5, but I'm getting 0.767. So it is, I have to reduce minus 0.17. So this have to be done using the back propagation. So in order to back propagate, this is error I have calculated. So how to do this? So each weight have to be changed accordingly. So this is the formula, delta Wij equal to mu dou j oj, where dou j equal to, this is the formula, and delta j equal to, this is the formula. So if j is an output unit, so if this particular j is an output unit, I have to use this value. If j is an hidden unit, if you are changing weight in the hidden unit, you have to follow this formula. Okay. So mu is a constant, learning rate, already learning rate was 1, and Tj is the correct output of j, and delta j is the error measure of unit j. So if you substitute here, we have to calculate the dou phi, we need use input of the forward pass. So y5, 1 of minus y5, target of y5. So I got here 0.67, what we got, and 1 minus what was our Wi-Fi, 0.67 into what was our error, minus 0.17. So I'll get minus 0.376. Now I'll substitute in your actual weight. So this is for hidden layers. So when I substitute for hidden layers, so my hidden layer value was 0.51, y3 was 0.57, and y4 was 0.59. When I substitute the values, these values in the formula, I got 0.0027 and 0.0819. So these are the values where I have to update the weight. Now, same values, I'm updating the weight. So this is the weight updation. So this is for W23. So the W2 second input to the third. Okay. So similarly, new is, so I got here 0.22184. So what I'm doing, old it was 0.9 plus I'm doing, so I'll update this particular weight. Okay, similarly, I'll update all the weights. Okay, so this is for W11, W1 new. So W11 plus W11 old, I'll get this value. So finally, when I'll update all the weight values, that is 1, 2, 1, 3, 2, 1, and 2, 2, and these are the weights we have updated. So when I do the again calculation, I'll get the Wi-Fi as 0.5, which is our actual output. Okay. So this is your target values. Done. So what exactly we have done? Just I want to brief 1 second, do my shoes. So what we have done first, yeah. Okay. So with the help of this particular HA value, I am calculating the summation. By you substituting Yj, that is f of Yj, I am getting Y3, Y4 and Y5. After getting Y5, what we have done? I calculated an error, that is Y target minus Y, that is 0.17. In order to reduce the error, all Wij, so this is for output unit, this is for hidden unit, I calculate this doj for all the required weights. Okay, so these are dou 5, dou 3, dou 4. Then, after getting this one, I updated the weights. Okay, so it is from 2 to 3, it is from 1 to 1. So new weight, finally I got all the new weights. So after updating all the new weights, again I have done the same values. So that is Y3 is this one, Y4 and Y5. So error rate, again it is little bit reduced. So this is an iterative process where you have to do this. So this is a process where we are going to use forward pass in order to calculate the output, backward pass in order to get the reduce the error and update the weights. Thank you.